Shell method, example 3. For this problem, we have a parabola. It's opening downward. So let me go ahead and draw this up for us. With this value here, this is a parabola basically in HK form. I know the vertex would be at 2, 1. So I'm going 1, 2, up 1. There's my vertex. There's my vertex. This thing has a standard opening, but it's opening downward. So I'll go right 1, left 1, down 1. Be here and here. So it's this little region. And we've got the y equals 0. With y equals 0, that is your x-axis. So it's this little region that we want to revolve about the x-axis. Now, if I could use any method I could choose, I would use a disk method. Why? This is going about the x-axis. This is screaming at me disk method because the height never changes. It's a solid piece. So it's going to look something like that. That would be really simple. But this is a shell method. They're forcing me. They're saying, hey, no, dude. We want this to be a shell method. So what's going to be a little weird about this is because I'm going about the x-axis, it tells me that these have to be the opposite of what I'm accustomed to. I'm going to have to do a dy for this problem. And if I'm going to do a dy, that means this has to be solved for x. Fortunately, not a terribly difficult thing to do here. To solve this for x, I'll go ahead and move the x minus 2 over. Make that y minus 1. I could root it. I could root both sides. As I root both sides, remember that this has to be a plus or minus. And so then I get this x minus 2 equals plus or minus rad 1 minus y. Then I can move that 2 over, so 2 plus or minus rad 1 minus y. That's what I'm looking at for a function now. If I'm looking at that as a function, I have to recognize that I'm going to have a top and bottom part. I'm going to have a top and bottom part when I talk about my height. Because we're slicing this way. We're slicing against the y-axis, so to speak. And so let's try to make sense of this. I'll try to explain how to set this problem up. As I look at this, I know I have these regions here. This region is 1, 0. This is 2, 0. And I'm actually interested in that peak. That peak was going to be 2, 1. So then I'm going to turn my paper just for a second so we can kind of see where we're at here. We're looking like this. Okay? As we're looking like this, this is going to be our axis of revolution. We're centered here at the y. We are going upward. I know I'm going to the left, but I'm actually going upward when I'm going like this, which means I have a positive y direction that I'm going. If I were to go this way, that's downward, and that'd be a negative y. So I'm going to set up my volume by saying this. Let's see if I can squeeze this in here. Volume is equal to the integral from y equal to y equal. Well, this first y equal value is y equals 0. See, I see here and there. And the second y value is 1. So I'm going to go from y equals 0 to y equal 1, 2 pi. Now my radius, what I was trying to explain to you a moment ago, I'm moving in a positive direction. I'm going upward. So I go out y units. I'm going out y units. So my radius is y. And then the height would have to be the positive part minus the negative part of that parabola. Okay? So the positive part of the parabola is going to be, I'm going to write it up here and then I'll transfer it down there. 2 plus radical 1 minus y. And to figure out this distance, this height here, top minus bottom, I have to subtract the negative part, which would be 2 minus radical 1 minus y. Now looking at our math here, 2 take away a 2, that's going to drop out, and this would become radical 1 minus y minus a negative radical 1 minus y. Minus negative is a positive, so it would be one of these radicals plus another one of these radicals, which would be 2 rad 1 minus y. And so I can bring this down here as my height, 2 radical 1 minus y dy. And that follows our structure. We got 2 pi r and then our height, depth dy. The thing that we constantly have to remind ourselves when you do the shell method, if you're going about the x-axis, everything's in terms of y. If you're going about the y-axis, everything's in terms of x. If it's something parallel, if I am parallel to the y-axis, like example 2 was, it's still a dy. If I'm parallel to the x-axis, it's still a dy. And so when we look at this, I have my 2 pi radius, height, dy. I can throw that in a calculator and I can tell you what this exact volume would be once it's been revolved about that x-axis. So there's our second example. There's our third example, pardon me, third example for the shell method.